Hi, my name is Sophie and I'm going to talk to you about the basics of evolution. I'm going to start with the theorists that over time have developed the ideas of evolution into what we have today. I'll start off with philosopher Aristotle. For almost 2,000 years, people were following his philosophy that individuals in a species are identical and species are unchanging. Sometime later, the idea of a special creation came about in the 1800s, meaning that organisms suddenly appeared on Earth for some planned purpose, but this idea excluded extinctions. George Louis Buffon. He said that closely related species have a common ancestor, and that species changed as they spread from their original location. James Hutton proposed the theory of uniformitarianism that said changes in nature are gradual. Georges Cuvier believed in the theory of catastrophism, where a species reappears after catastrophes. He used his knowledge of anatomy to identify similarities between extinct organisms and fossils to organisms in his time. He proposed the idea of the principle of superposition, which is the idea that lower layers of rock, including fossils, are older than those above them. He refused to believe that species had become extinct or not originally from creation. Jean-Baptiste de Lamarck proposed the first scientifically testable evolutionary theory that new species come from existing species through environmental forces. Charles Lyell renewed uniformitarianism and suggested that Earth is perhaps hundreds of millions of years old. He said all changes in nature are gradual. Charles Darwin and Alfred Russel Wallace. Darwin tried to reconstruct the past through contemporary observations and question the location of fossils. With assistance from bird expert John Gould, economist and theologian Thomas Malthus's essay on the principle of population, and the developed ideas of other theorists, Darwin summarized the ideas of natural selection to describe, as quoted, this preservation of favorable variations and the rejection of injurious variations. After receiving a manuscript about how natural selection was the driving force of evolution from Alfred Russel Wallace, Darwin published On the Origin of Species by Means of Natural Selection in 1858. In the time of Darwin, Gregor Mendel was working out the kinks to inheritance. Scientists unified the ideas of natural selection and genetics in the 1930s and called it the modern evolutionary synthesis, which suggested that genetic mutations created heritable variation and that this variation is what natural selection acted on. In the 1950s, after the discovery of DNA structure, scientists found that sexual reproduction shuffles alleles to produce genetically different offspring and amplifies this variability. Natural selection is based off the idea of survival of the fittest. This means that individuals with the best adaptations are most likely to reproduce. Adaptations are features that provide a selective advantage because they improve an organism's ability to survive and reproduce. Allele and genotype frequencies determine the genetic characteristics of a population. Now, one might ask, why doesn't this natural selection produce one superorganism? And this is because that superorganism won't be able to adapt to every possible habitat on Earth. An example would be trout, which has adapted to cold waters because they live in streams, but they won't do too well in Sahara Desert. One might think that humans are the superorganisms, but humans can't withstand extreme temperatures. We can't live in the Arctic very long without a coat, and we can't survive in the center of the Earth. And there's also something called the Hardy-Weinberg equilibrium. But this is against evolution and the change of allele frequencies and genotype frequencies from one generation to the next. In reality, allele frequencies always change, and we have many, many, many facts to prove that this cannot be true. There is proof against the Hardy-Weinberg equilibrium, and this is just some of it. Mutation introduces new alleles. There's 5 types of mutation: normal gene, point mutation, deletion, insertion, and frameshift. Individuals mate amongst themselves rather than random mating. Individuals migrate amongst populations. Allele frequencies change due to chance, called genetic drift. Genetic drift is random change in allele frequencies due to sampling error. Some phenotypes are better adapted to the environment. Phenotypes are a set of observable characteristics resulting from the individual's interaction of its genotype with the environment, and this supports natural selection. There are 3 types of natural selection. Please note, in the diagrams, the up arrow means that the frequencies in the phenotype are being selected for natural selection, and the down arrow signifies that the frequencies of phenotypes are being selected against natural selection. The first type of natural selection is directional. Directional selection means one extreme phenotype becomes more prevalent in a population. The second type is called disruptive, which is where multiple extreme phenotypes survive at the expense of intermediate forms. Stabilizing selection means an intermediate phenotype has an advantage over individuals with extreme phenotypes. And these are the 3. So basically, it's taken a lot of theories to get to what we believe evolution is today and what supports it. The Hardy-Weinberg equilibrium is false because allele frequencies change with natural selection, meaning that if your phenotype is adapted for the environment, it will be inherited in the next generation, and if it's not, it'll disappear. And thank you for watching.